Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series on architecture. Name of the subject is Mechanics of Structures 1 and we are in Unit 2, which is Analysis of Plane Trusses. This is lecture number 6. Content of this lecture is Analysis of Cantilever Truss by method of joints. We are going to see a numerical problem in this. Here in this figure, we have a cantilever truss. A cantilever truss is a one in which one end of the truss is fixed. Actually, the ends D and E, that is joints D and E are fixed, and the other end, that is end A, is free, and hence this truss is a cantilever truss. At the free end A, we have a force of 10 meganewton acting in the downward direction. Total span of the truss is 8 meters. We are asked to find the forces in all the members of this cantilever truss by method of joints. So, this cantilever truss has 6 members. We have to determine the forces in all these 6 members by method of joints. Unlike simply supported beams, there is no need to calculate any support reactions for a cantilever truss. Now, first of all, we shall consider the free end or the joint which is at the right hand end, that is at the free end. So, we are considering the free body diagram of joint A first. At joint A, we have a downward force of 10 meganewton acting. We have the member CA meeting at joint A. Let FCA or FAC be the force in that particular member. We shall assume tensile force for that particular member. So, the arrowhead should point away from this joint A. Also, there is another member BA coming in joint A. Let the force in that particular member FBA. We shall assume compressive force for this particular member. So, the arrowhead should point towards this joint. Now, for this truss, the inclination between the members are not given. From the dimensions of the truss given, we shall calculate the angles. The angle BAC, that is this particular angle, will work out to be 23.56 degrees. So, this remaining angle will be 63.44 degrees. So, this angle is 63.44 degrees, 63.44 degrees. Now, we shall apply the conditions of equilibrium for getting the 2 unknown member forces FBA and FAC. First of all, we shall apply the condition sigma V equal to 0, algebraic sum of all vertical forces at joint A is 0. This 10 meganewton force is acting in the downward direction and hence it will have minus sign. So, minus 10. Now, let us consider FBA. The force FBA goes in this particular direction, that is it starts here and it ends up at joint A. So, it starts here and it ends up here. To travel along this path, horizontally we have to move towards right and reach this particular point, and then vertically we have to go upwards. So, if we see the vertical component of FBA goes in the upward direction. So, its sign will be plus. Now, this particular angle is 63.44 degrees. So, with respect to this 63.44 degree, vertical component of FBA is the adjacent side of the right angle triangle. So, the vertical component will be plus cos 63.44 degree into FBA. Already we have minus 10. So, plus F B A into cos of 63.44 degree. Now, the next force is FAC. FAC is a horizontal force and hence it does not have any vertical component. So, these are the algebraic sum of all vertical components of forces. I am equating it to 0. Now, solving this equation we will be getting F B A as plus 22.36 meganewton. FBA comes as positive, which means that our assumed nature of force in the member BA, which is compression, is right. So, FBA will be 22.36 meganewton compressive. Now, let us apply the second equilibrium equation, that is equilibrium condition, which is algebraic sum of all horizontal forces at joint A is 0. This 10 meganewton force is vertical force, it does not have any horizontal component. FAC, it is a horizontal force, it goes towards left. So, we should put a negative sign for it. So, minus FAC. Now, let us get the value of horizontal component of FBA. Now, this is the horizontal component of FBA. Horizontal component of FBA goes towards right. So, it should have a positive sign. With respect to this 63.44 degree, horizontal component H is opposite side of the right angle triangle, and hence horizontal component will be plus FBA into sine of 63.44 degrees. So, we shall put that value here, plus FBA into sine of 63.44 degree. So, this is the algebraic sum of all horizontal forces. I am equating it to 0. Already we have found out the value of FBA, which is 22.36 meganewton compressive. Using that value in this equation, we get FAC as 20 meganewton. Once again, sign convention is positive here, that is it is plus 20 meganewton, which means that our assumed nature of force for the member AC, our assumed nature of force here is tensile, is also right. So, FAC will be 20 meganewton tensile. So, by considering joint A, we have found out two unknown member forces, which are FBA, which is 22.36 meganewton compressive, and FAC, which is 20 meganewton tensile. Now, we shall go for the next joint. The next joint that will be considered here will be joint B. We cannot consider joint C because there are totally 4 members meeting at joint C, in which we have only one member in which we have found out the force. So, in the remaining 3 members we do not know the value of forces, and hence we should not consider joint C. Now, we shall consider joint B. Let me draw the free body diagram of joint B. Three member forces at joint B are FAB, FBC and FBE. Already we have found out the magnitude of the force FAB, which is compressive. The nature of force in the member AB is compressive, hence arrowhead should point towards the joint B. Now, I am assuming that the force in member B is also compressive in nature. So, the arrowhead once again for FBE is pointing towards joint B. Similarly, FBC is also assumed to be compressive. So, arrowhead points towards the joint B. The angle between the members BC and AB will be 63.44 degrees. Now, let us apply the conditions of equilibrium. The first one is sigma V equal to 0. Now, FBC is a vertical force, it goes in the downward direction. So, negative sign should come for FBC. So, minus FBC. FBE is a horizontal force, hence it does not have any vertical reaction component. Now, we shall find out the vertical component of the force FAB. FAB goes like this, that is it starts here and it ends up at joint B. So, it starts here and it ends up at joint B here. So, this is our joint B. So, to travel along this particular path horizontally we have to move towards left till this particular point and then vertically we have to come down. So, this is the horizontal component h of FAB and this is the vertical component of FAB. Since the vertical component of FAB goes in the downward direction, sorry, it is minus, this angle is 63.44 degrees. Now, vertical component of FAB goes in the downward direction, so it should have a minus sign. With respect to this angle 63.44 degree, vertical component is the adjacent side of the right angle triangle. So, the vertical component would be FAB into cos of 63.44 degrees. Now, let us come to the horizontal component of FAB. Horizontal component of FAB moves towards left. So, according to our sign convention we are putting a minus sign. With respect to 63.44 degree, this horizontal component is opposite side of the right angle triangle. So, the horizontal component h will be minus FAB into sine of 63.44 degrees. Now, here we are applying the equilibrium equation sigma v equal to 0 for joint B. So, FBC is negative. So, minus FBC. Now, vertical component of FAB is minus FAB into cos of 63.44 degree. So, these are the algebraic sum of all vertical forces. I am equating this to 0. Already we have found out the value of FAB. Putting the value of FAB in the above equation, we can get the value of FBC. FBC comes as minus 10 meganewton. Minus sign indicates that our assumed nature of force for the member BC, our assumption is that it is compressive in nature is wrong and hence FBC should be tensile in nature. So, therefore, FBC, so it is minus 10 meganewton compressive. So, minus sign implies that it is not compressive, it should be tensile. So, FBC is 10 meganewton tensile. Now, let us apply the second equilibrium equation, which is sigma h equal to 0. FBC is a vertical force, FBC is a vertical force, it does not have any horizontal component. FBE is already a horizontal force, it moves towards right. So, we should have a positive sign for it. So, plus FBE. Horizontal component of FAB is minus FAB into sine of 63.44 degrees. We shall put that here minus FAB into sine of 63.44 degrees. This is equal to 0, from which we can get the value of FBE. FBE comes as 20 meganewton. If you see the sign here, it is positive, which means that our assumed nature of the member force for the member AB, that is compression, is right. So, FBE is 20 meganewton compressive. Now, let us move on to the next joint, which will be joint C. I am drawing the free body diagram of joint C here. Joint C is acted upon by 4 forces, which are FCA, FCB, FEC and FED. Already we have found out the direction as well as magnitude of the 2 forces FCA and FCB. FCA is 20 meganewton tensile. Since it is tensile in nature, arrowhead should point away from the joint. FCB is 10 mega Newton. Once again it is tensile. So, arrowhead should point away from the joint. Now, for FDC I am assuming compressive force. So, arrowhead is pointing towards the joint, and for FCE I am assuming tensile force. So, arrowhead points away from the joint. After assuming suitable nature of force for all the members, we shall apply the equilibrium equations, conditions of equilibrium. The first condition will be sigma V equal to 0, algebraic sum of all vertical forces equal to 0. FCA is a horizontal force, it does not have any vertical component. FCB goes in the downward direction. So, it is minus FCB. Let us consider the force FDC. FDC acts like this. It starts from this particular point and it ends up at joint C, that is it starts here and it ends up here. To move along this particular path, vertically we have to come down till this particular point, and horizontally we have to move towards left. This angle is known to us, which is 23.56 degrees. So, this is our vertical component V and this is the horizontal component H. With respect to 23.56 degrees, vertical component is opposite side. Also the vertical component goes in the downward direction. So, we should have a negative sign for it. So, vertical component V will be minus FDC into sine of 23.56 degree. Horizontal component of FDC moves towards right. Since it is moving in the right hand side direction, we should have a positive sign for it. So, magnitude of H will be plus FDC into cos of 23.56 degree. Now, we are applying the condition sigma V equal to 0. We need the vertical component of FDC, which is minus FDC into sine of 23.56 degree. So, we have considered FCB, we have found out the vertical component of FDC. Now, we shall come to the force FEC. Force FEC. The force FEC goes like this. This is FEC. It starts from the joint C. This is our joint C, and it ends up here. It starts here and it ends up somewhere here. So, FCE starts here and it ends up here. To travel along this particular direction, horizontally we have to move towards left till this particular point, and vertically we have to come down. So, this particular angle is 23.56 degree. So, this is the horizontal component of FCE and this is the vertical component of FCE. Horizontal component of FCE moves towards left. So, it should have a negative sign. Horizontal component will be FCE into cos of 23.56 degree. Similarly, vertical component of FCE, vertical component goes in the downward direction. So, it also has a negative sign. Vertical component V with respect to 23.56 degree is the opposite side of the right angle triangle. So, we will have minus FCE into sine of this angle, which is 23.56 degree. Now, we need only the vertical component of FCE, which is minus FCE into sine of 23.56 degree. So, now we have found out the algebraic sum of all vertical components of forces. I am equating it to 0. Already we have found out the force in the member CB, that is we know the value of FCB. So, upon simplifying this equation, we get FCE plus FDC will be equal to minus 22.36. Let us keep this as equation number 1. So, equation 1 is obtained by applying the condition sigma v equal to 0. Now, we shall apply the second equilibrium condition, which is sigma h equal to 0. So, sigma h equal to 0, algebraic sum of all horizontal forces acting at joint C is 0. F C B is a vertical force, hence it does not have any horizontal component. F C A moves towards right, it is a horizontal force and it is going towards right. So, we should have a positive sign for it, plus F C A. Now, let us get the horizontal component of the force F D C. Now, in this triangle, horizontal component of the force F D C is plus F D C into cos of 23.56 degree. So, plus F D C into cos of 23.56 degree. Next, we need the horizontal component of the force F C E, which is here. Horizontal component of force F C E is minus F C E into cos of 23.56 degree. We are equating this as 0. Already we know the value of F C A. So, simplifying this equation, we will get F D C minus F C E, which will be equal to minus 22.36. We shall take this as equation number 2. Now, we have equation 1 here and this is the second equation. There are two equations with two unknowns. Solving these two simultaneous equations, we can get the value of F C E and F D C. To get that, we shall add equation 1 and 2. Equation 1 added with equation 2, we will be getting this F C E and F C E will be cancelling out. So, we will be getting 2 times F D C which will be equal to minus 44.72, or F D C will be equal to minus 22.36 meganewton. Negative sign here indicates that the assumed nature of force for the member D C, that is compressive, is wrong, it is incorrect, and hence it should be tensile. So, therefore, F D C is 22.36 meganewton tensile. Now, we can use the value of F D C in equation 1 or equation 2 in order to get the value of F C E. Now, we shall put this value in equation 2. So, F C E, equation 2 is F C E plus F D C, which is equal to minus 22.36. F D C by magnitude for our original assumed direction is minus 22.36. So, F C E minus 22.36 is equal to minus 22.36. Therefore, simplifying this, we get F C E as 0, which means that there is no force acting in this member E C. So, member E C is devoid of any force. Only in the rest of the members we have forces acting. To summarize the things which you have learnt in this particular lecture, we have seen an example problem for the analysis of cantilever truss by method of joints. Students can answer this particular problem. Determine the forces in all the members of the cantilever truss shown below by method of joints. Now, figure shows a cantilever truss of span 4 meter. At the free end of the cantilever truss, that is at joint B, a vertical downward force of 20 kilonewton is acting. This cantilever truss is fixed at joints A and E. You are asked to determine forces in all the members of the truss. Totally there are 4 members in which you have to find out the forces, for which you have to find out the member forces. With this we have come to the end of this lecture. Thank you.